Let's take a look at question 21. So we have equilateral triangle and three squares. One side of the triangle is 20. They want us to find the distance between the point A and point B. So the first thing is that we connect AB. Then we can label these 2 points C and D. Now, we know that this is a right angle plus a 60 degree, so that's 150. Now let's draw a line that's perpendicular to AB. So we get a right angle here. This is the right angle, which means that this part is 60 because the total is 150, which means that this triangle is a right angle triangle that contains 30 degree, 60 degree, and 90 degree. Let's call it point E. Let's do the same for the other corner. We can call it point F. Then this part is a right angle, a 60 degree, and a 30 degree. Right, so CD is 20, which means that EF is also 20. So EF is 20. Now let's look at a square. So let's look at a triangle ADE. AD is 20. That's from the square. Now for this triangle, we know that the shortest side, DE, is half of the longest. This is always true for a triangle that contains a 30 degree. So this part D is 10. If D is 10, the AE is 10 times square root 3. Alright, you can use Pythagoras theorem. Okay, because it will be, right, let's write it down. This part AE square equals to AD square minus DE square. So that's 20 square minus 10 square. The 400 minus 100 equals to the square root of 300. Oh. So square root of 300 is simplified. This 3 times 10 square. If you take out the 10 square, that part is 10. Okay, this is 10 square root 3. Okay, maybe write one more step. Okay, 3 times 10 square is square root 3 times square root of 10 square. Now square root of 10 square is just 10. So it's 10 times square root 3. Since the figure is symmetrical, then we will know that if AE is 10 square root 3, then BF is also 10 square root 3. This is 10 and 20. Okay. So let's add them together. A plus B, this equals to 20 plus 20 times the square root 3. Now let's put the 20 back into the square root. So this is 20 equals to the square root of 400 times square root 3. So it's 20 plus square root of 1200. Right, wait, this is A plus square root B. Okay. So which means that A equals to 20, B equals to 1200. So we add 20 and 1200 together. That's 1220. Question 22. Okay, we have two different positive integers. Let's call them A and B. This is called a beautiful number pair. If one number is at least 25% of the other number, so if B is the smaller number, it will be at least 25% of A, which means that A is 4 times of B. Uh, So if B is the larger number, A is 25% of B, which means that the B is 4 times of A, so B is less than or equal to 4 times of A. And then if if A is the smaller number, no, if B is the smaller number, so is at least 25% of A, which is a quarter of A. So B must be between these two values. Let's try the different cases. If A is 25, so 25 over 4, that's 6.25. 4 times of 25 is 100. So B must be from 7 to 100. And since the numbers cannot be the same, so we need to minus the 25. Let's check how many ways are there. From 7 to 100, we get 100 minus 7 plus 1. The 94 numbers. But we are not counting the number 25, so because A and B must be different. So minus 1. Yeah, this 93 weights. Level A is 26. Oh, so B now is a number from 7 to 104. Yeah, 4 times 26 is 104. And this time is except for 26. B cannot be the same as A, so take out the number 26. We check the number of terms 104 minus 7 plus 1. The 98 numbers, take out the number 26, then the 97 left, 97 weights. So when A is 27, B is a number from 7 to 108, except for the number 27. Then this is 108 minus 7 plus 1. We get 102 numbers, take out the number 27, that's 101 numbers. Well, A is 28, B ranges from 7 to 112. Again, it cannot be the same. So except for the number 28. Then we have 112 minus 7 plus 1. Take out the number 28. The 105 numbers left. Okay, then we'll notice that some of the number are counted twice. You see, when A is 25, B can be 26. And when A is 26, B can also be 25. So 25, 26 is the same as 26, 25. That's counted twice. Then 25, 27 is the same as 27, 25. 25, 28 is the same as 28, 25. Then 26, 27, 26, 28, 27, 28. So you choose any two numbers from here, you get a pair, which is 4C2. So there are 6 pairs that's counted twice. So we need to minus 6. So we use the total 93 plus 97 plus 101 plus 105 minus 6. The answer is 390. Question 23. This is related to the triangular numbers. We see the first row there's one number. Second row there are two numbers. Third row there are three numbers. Then 4 and 5. But since these are only the odd numbers, so let's check how many odd numbers are there. This odd number from 1 all the way to 2025. So the last number minus the first number. Every time we plus 2 to get the next number, divided by the common difference, which is 2. After that, plus 1. There are 1013 odd numbers here. Right, let's find the row number. So after some calculation, we get that from 1, if you add all the way to 44, this is half times 44 times 45, which is 990. And if you add from 1 to 45 together, this will be half times 45 times 46. That's 1035. So the 1013 is between these two numbers. 990 less than 1013. 1035 is greater than 1013. So until the row 44, we have 990 odd numbers. Until the row 45, we have 1035 odd numbers. Means that this number 2025 is on the row 45. It's after the row 44. So row 45 contains the number 2025. We want to find a number that's directly below 2025. Right, let's check the difference between numbers in each row. If you look at row 4 and row 5, difference is 8. There's always plus 8, which is 2 times of the row number. So if it's from row 45 to row 46, difference between the number would be 2 times of the row number 45. Because each of them is 45 terms later. And these are odd numbers, so it's plus 2 each time. Okay, so it's plus 90. This number is 2115. For question 24. So at first we have a rectangle. It's given to us that the length is 2 times of the width. So let's say the length is 2u, the width is 1u. Now, if we shorten the length by 14 and increase the width by 8, so we get a new rectangle. Now, let's say this part is 2u minus 14. Then this part is 1u plus 8. Give us the same area. Then let's find the area for the original rectangle. There's 2u times 1u. For the new rectangle, it's 2u minus 14 times 1u plus 8. Right, so we get 2u squared. Now 2u times 1u, that's 2u squared. And 2u times 8, that's 16 units. Minus 14 times 1u, so minus 14u. And then lastly, this is minus 14 times 8, so minus 112. Now after we expand the brackets, we can cancel out the numbers. 2u squared cancelled. And this is 0 equal to 2u minus 112, which means that 2u equals to 112. So 1 unit equals to 56. Now, if 1 unit is 56, we can find the length and the width of the new rectangle. So the length is 2u minus 14. 2 times 56 minus 14. This equals to 98. The width of the new rectangle is 1u plus 8. So 56 plus 8. That's 64. So the perimeter of the new rectangle, 98 plus 64 times 2. The answer is 324. Now, let's take a look at question 25. Yeah, we are looking at 4-digit numbers that contain exactly one pair of identical digits. Oh. So first we can choose the position for the pair. The pair of identical digits can be any of the 4 digits. So that's 4C2. That's 6 ways. Then let's check after you select the position, how many different arrangements are there? So first we can try AA, BC. Now the A is 9 ways. Second A follow the same number 1 way. And B can be a number from 0 to 9, but it cannot be A, because we already contain 2-digit A. So this is 10 minus 1, 9 ways. And now out of the 10 digits, we have used 2 A and B. So 10 minus 2, C is 8 ways. That's 9 times 9 times 8. And if we check a different arrangements, let's say if you check A, B, A, C, this will be the same. A is 9 way. B is different from A, so 10 minus 1, 9 ways. Second A is 1 way. And after we use 2 digits, C is 10 minus 2, 8 ways. It's also 9 times 9 times 8. Right, if it's A, B, C, 8, this will be the same 9, 9, 8, 1. And if we put the A in the middle, BAAC, okay, the B can be any number from 1 to 9. And since the A and B are different, so A is 10 minus 1, 9 ways. Second A is 1 way. And C is 8 ways. C is different from both A and B. And we can also have BA, CA. B is 9 ways. Now A is different from B, so 10 minus 1, 9 ways. C is different from both A and B, 10 minus 2, 8 ways. Second A is the same, 1 way, is 998. And the last one is BCAA. B is 9, C is 9, different from B, 10 minus 1. Now A is different from both A and B, that's 8. Second A is one way. Also 9 times 9 times 8. Right, you can see out of these 6 positions, 1, 2, 3, 4, 5, 6. The number of ways are always the same. It's always 9 times 9 times 8. So the total is 6 times of 9 times 9 times 8. The total is 3888. Now, question 26. So this one is asking how many 2 by 3 cards with a different pattern are there? Now, if you can get the same pattern after rotation, and you can also flip the paper, means you can flip it to the other side of the paper, where the black becomes the white becomes the black. Then that's also considered the same way. So the first thing we know that if you have 6 black, if you flip it, it becomes 6 white. And if you get 5 black, 1 white, let's write it the other way, 6 white, 6 black. If you got 5 white, 1 black, if you flip it, then you get 5 black, 1 white. Because the opposite side of the black square is white. The opposite side of the white square is black. And if you got 4 white, 1 black, flip it, then you get 4 white, 2 black. After you flip it, you get 4 black, 2 white. And if it's 3 white, 3 black, you flip it, you get 3 black, 3 white. So we don't have to check for everything here, because after flipping is the same, that's considered the same way. We are only considering half of them. We're considering these 4 cases. Now let's start from the easiest case, which is 6 white. So 6 white, there's only one way. If it's 5 white, 1 black, so we check position of the white, position of the black. Now, you can place it on the first row. This one, if after rotation, it goes to this part. So those two are the same. Then you can put it in the middle. After your rotation, it goes to the second row. Third position is here. If you do it after the rotation, it goes to this corner. So this is 6C1. Total is 6 ways. But we are only taking half of them. Because the remaining half we can get them from rotation. So there's 1 way for 6 white, 3 ways for 5 white, 1 black. Then next we get 4 white, 1 black. Four white, 2 black. Okay, first you consider the total. Out of the 6 position, you make 2 of them to be black. The 6C2. Now 15 ways in total. But out of the 15 ways, some of them are special. Because for some of them, after rotation is still the same. First one is like this. After rotation is still the same pattern. Second one is you put 2 in the middle. After rotation is the same pattern. Third one is like this. So these 3 ways are special. Because it's already the same thing after rotation, so there's no double counting here. So we minus 3 first, 12. Now the remaining 12 ways is like just now. After rotation, you get a different pattern. Those two are considered the same way. So divided by 2. That part is 6. Then we add in these 3 special patterns. There's 9 ways in total. Yeah. So it means that out of the 15 ways, we divided into 2 groups. The 3 are special. There's no double counting because after rotation is the same. But for the other 12, after rotation, you get a different pattern. But since you can get it from the rotation, so those are considered the same. That's why you need to divide by 2. This is 6 plus 3. Total is 9. Now, 3 black. 3 white, 3 black. Okay, so we know that the total is 63. There are 20 different patterns. Okay, then we are going to group them together. So let me draw the 2 by 3 rectangles first. Yeah, there are 2 types. The first type, yeah, so this one, after rotation, becomes like this. So these 2 are considered as the same way. Then if it's originally like this, after the rotation, this goes to the top, the other 2 goes to the bottom row. These are also considered the same. And the next one is you can put it like this. 1 in the second row, 2 in the first row. After rotation, these 2 goes to the second row. That one goes to the first row. They are also the same. And lastly, you can have these 2 separate. This one in the middle. After rotation, it's like this. Alright. So these 2 are the same. It's considered as one way. These 2 are the same, considered as one way. These 2, the same, considered as one way. These 2 are the same after rotation, considered as one way. So altogether, there is 8 divided by 2, 4 ways. That part is 4. Now, for the other 12 ways, so you can get it from rotation, also the flipping. Okay. This one, if you rotate, let me get this figure. But if you flip it to the other side, Right, after flipping, we can get this. The other one, if you flip, you get this. So everything here is considered as one way because you can get it from the rotation or flipping. These four considered as one way. Next, you can put two here, put one here. Okay, if we rotate, it becomes like this. Then if you flip it, and it becomes like this. Then you can also do the rotation. So these are considered as the same way. You can get them from the rotation or flipping. Lastly, we can put the shader to the bottom. And then if we flip it, this goes to the top. And this is after rotation. Then if you flip it, the other side, we get this. Then you rotate, we get this. So these four are considered the same. So out of the 12 ways, every four of them is considered the same. So divide by 4. This is 3 ways. Altogether, the 7 ways. Now we add everything together. Let's find it. We got 1 way, 3 ways, 9 ways, 7 ways. So the total is 1 plus 3 plus 9 plus 7 equals to 20. Now, question 27. So we are given a 4-digit number. Let's call it ABCD. So what happens now is it Mr. Zhong counted 9 more soldiers, means the number plus 9. Okay, after we plus 9, that will be carried over to the next digit. So the next digit plus 1, this digit minus 1. Then the next person swap the first and the third digit. So now the first digit is C plus 1. Wait, no, this person, Mr. Wang, swap the last 2 digits of the number. So we swap these two. It becomes AB. Then third digit is D minus 1. The last digit is C plus 1. After that, the next person swap the first and the third. So D minus 1 is the first digit, followed by B, followed by A, followed by C plus 1. The last step, times 2. Okay, Mr. Wu multiplied the number by 2, and we get a starting number. The starting number, ABCD. So let's just focus on the second last step. This is the number D minus 1 for the first digit. Second digit is B. Third digit is A. Last digit is C plus 1. Now when this added to the number itself, so it's added to D minus 1, B, A, C plus 1. If we add them together, This equals to A, B, C, D. First thing is that C plus 1 plus C plus 1 is the same number added to itself, so D must be even. D is an even number. And you look at the first digit, there's no carryover to the next digit. So we know that D minus 1 is less than or equal to 4. Okay, it cannot be 5. Okay, so it's let's just write it this way. This is less than 5. If it's 5, the 5 plus 5, this is 10. Carry over to the next digit, but it's only a 4-digit number. The other thing we know is that the first digit cannot be 0, so D minus 1 is the first digit of the 4-digit number. It must be greater than 0. From there, we can find that D is greater than 1, less than 6. And since D must be even, so D can only be 2 or 4. Right? So we just need to check for 2 cases. Now, suppose D is 4. If this is 4, then D minus 1 equal to 3. This is 3 plus 3. And look at this part, B plus B equals to B. So either there's carryover, if there's a plus 1, then B is 9. If there's no plus 1, then B must be 0. So we check them separately. And this part, since 3 plus 3, A is at least 6. So A plus A, there must be carryover to the next digit, which means that this B must be 9. 9 plus 9 plus the carryover 1 equals to 19. Carryover 1 again. Then we get that A is 7. Right, let's see if it works. If this part is 7 plus 7 equals to 14. If this is 14, which means that C plus 1 is 5. But 5 plus 5 does not equal to 4. This means that when D is 4, we get a contradiction. This is wrong. Yeah, so we can try the other case. The other case is when D equals to 2. So we do it by the same method. If D is 2, D minus 1 equals to 1. There's 1 plus 1. Now 1 plus 1 is 2. If there's carried over, A equals to 3. So A is 2 or 3. Now even if A is 3, there's no carryover to the next digit. No carryover. So B must be 0. 0 plus 0 equal to 0, which means that 1 plus 1 equals to 2. So A is 2. This part is 2 plus 2. C equals to 4. So for the ones digit, this cannot be 4, right? If it's 4, then we get 5 plus 5, which equals to 10. So there must be carryover here. After the carryover, there is a 5, which means that C plus 1 is a 6. The 6 plus 6 equals to 12. Carryover 1, so 1 plus 2 plus 2, there's 5. Alright, so now we have the original number. A is 2, B is 0, C is 5, D is 2. That's 2, 0, 5, 2. For question 28, we want to find how many different obtuse triangles can be formed. Now let's label these points. Let's label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's say if we got a circle around this polygon, then for this circle, we can look for the diameters. So if we draw a circle around these points, then we get the diameters. The diameters can be 1, 7. If you can see, connect 1 and 7, this is the diameter of the circle. Or it can be 2 and 8. It can be 3 and 9, 4 and 10, 5 and 11, and lastly 6 and 12. There are 6 different diameters in the figure. And in circles, we know that if you select the diameter as one side of the triangle, you choose any other points, this will give us a right angle triangle. You can choose any points here. So when you use the diameter, it's always a right angle triangle. Then if you want it to be an obtuse triangle, just choose a line that's less than the diameter. Now if you connect them, this angle is greater than 90. That's an obtuse angle. You can choose 1, 2, and 3. This obtuse triangle. You can choose 1, 2, and 4. 1, 2, and 5. Or you can choose 1, 3, and 4. 1, 4, and 6. These are all obtuse triangle. So let's see, if we choose point 1. Okay, if we choose point 1, then for the other 2 points, you can choose from the 2 to 6, which is 5C2. That's 10 ways. Alternatively, you can choose from the 8 to 12. That's another 5C2, which is another 10 ways. So we can form 20 obtuse triangles that contain the point 1 here, when 1, 7 is the diameter. Okay, you can choose a point 1 and 2 of the points from 2 to 6. Or you can choose a point 1 and 2 of the points from 8 to 12. This way we can form 20 triangles. And since we can choose any of the 12 vertices, so you will be, right, you choose point 2 is also 20 ways. You choose the point 3 all the way choose the point 12. These are all 20 ways. Together, we have 20 times 12. 240. But one thing to take note is that some of the triangles, in fact, some of the triangles are counted twice. For example, let's look at the triangle 1, 2, and 3. Right. So we get this when we are checking the point 1, where 1, 7 is the diameter. Now let's change the diameter. If we choose 3, 9 as the diameter, this is when you are checking for point 3. Then we also need to count this triangle. Right? That's also one of them. So this triangle is counted twice. So like the triangle 1, 2, and 3 is counted twice. This one is when you're checking the point 1 and the point 3. In fact, this is true for all the other triangles. Let's say you check this triangle. If we get a different one. Okay. Now if you do 1, 3, and 4. The same triangle is also counted when you are checking for 4. Alright, you do 4, 3, and 1. So every single triangle is counted twice. Okay, so let's write every triangle is counted twice. So we need to divide by 2. 240 divided by 2 is 120 ways. Now, question 29. So we can arrange this, classify these numbers according to the remainders when divided by 5. The first column, everything is remainder 1 when divided by 5. Second column, everything is remainder 2. Third column is remainder 3. The fourth column, remainder 4. And the fifth column, remainder 5. Oh, we read remainder 0. Okay. So if you check the sum of numbers within the rectangle that's chosen, it will be deciding whether this is divisible by 5. It just equals to the sum of the numbers in the row. Suppose you choose these 3 numbers in the row. Right? So sum of the remainders times the number of rows. Sum of the remainders in the row times the number of rows. Right? So if you choose 2 rows, the sum of remainder times 2. If you choose 3 rows, the number of remainder times 3. Let's consider the different cases. First, if you choose number from all 5 rows, right? For each row, let's say if you select one number, so if you select the number R1, 5 of them is R5, that's divisible by 5. If you choose the number R2, 5 of them, that's divisible by 5. If you choose the number R3, 5 of them divisible by 5. And same for R4 and R0. So for each row, if you choose one number, there are 5 ways. Then if you choose 2 numbers, so it can be R1, R2, R2, R3, R3, R4, or R4, R0. That's 4 ways. If you choose 3 numbers, that's 1, 2, 3. Choose 4 numbers is 2 ways. If you choose all 5 numbers, that's 1 way. So when we select all 5 rows, there are 15 ways. Then we check the other cases where you choose one row, any number from 1 to 4 rows. Choose a number from 1 to 4. Then we have to make sure that the sum of remainders in the row is divisible by 5. Because if you're just choosing, let's say you choose 2 rows, times 2, if the original number is not divisible by 5, it doesn't matter if you times 2 or not. So for the numbers in the same row, we need to choose them such that it's divisible by 5. So for numbers in the row, If you're just choosing one number, you must select the number from R0 from this column. If you're choosing two numbers, you can choose these two columns. Choosing three columns it can never be divisible by 5. And you can choose four columns, the first four, R1, R2, R3, R4. Lastly, you can choose all 5, which is also divisible by 5. So there are 1, 2, 3, 4. 4 different ways. Let's check how many ways are there to choose the rows. If you're just choosing one row, there are 5 ways. Choose two rows. There's 1, 2, 3, 4. 4 ways. Choose three rows. 1, 2, 3. If you choose 4 rows, there are 2 ways. 1, 2. Now we already checked the cases where you choose all 5 rows. So this is only until 4. This will be 4 times 14 equal to 56. Then we add them together. 15 plus 56. The total is 71. Now let's move on to question 30. So they want to find the 4-digit numbers. If you separate it into the first 2 digits and the last 2 digits, like the number 2025, and then after that you add them together, 20 plus 25 is 45, and you square it. 45 squared is the original number, 2025. They are looking for the other two number that has this property. So to do this, we can look at the number ABCD. Now ABCD just equals to 100 times of AB plus CD. It's 100 times of the first 2 digits plus the last 2 digits give us the original number. Right, to make it easier, let's just say X equals to AB, Y equals to CD. So now ABCD is 100 times of X plus Y. So we have 100X plus Y equals to the sum of X and Y, then you square it. So the bracket X plus Y squared. So to solve it, let's separate the 100X into 99X plus X plus Y equal to X plus Y bracket squared. Let's minus X plus Y, minus the X plus Y from here. So we get 99X equals to X plus Y bracket squared minus X plus Y. Now we group them together. The common factor is X plus Y. The front part is X plus Y times X plus Y. Second one is X plus Y times 1. So there's minus 1. So now we know that X plus Y times X plus Y minus 1, which are two consecutive numbers. The product is a multiple of 99. Yeah, there's a multiples of 99. And now if this is divisible by 99, then we can check for the value of x plus y and x plus y minus 1. Okay, 99, which is 9 times 11. Right, it will be easier to check for 11. X plus y minus 1 times x plus y. We want the product to be divisible by 99. Now just make one of the number to be a multiple of 11. You check whether the other one is divisible by 9. So we got 10 times 11. This one cannot. It's not divisible by 9. 11 times 12, not divisible by 9. The next one is 22. So 21 times 22. 22 times 23. They are not divisible by 9. Then the next multiple of 11 is 33. So 32 times 33. 33 times 34. Again, they are not divisible by 9. Next multiple of 11 is 44. So we get 43 times 44. 44 times 45. So we have found the first group. Now 44 times 45. This is divisible by 11 and 9 at the same time. Let me check the next group. Next multiple of 11 is 55. So 54 times 55. 55 times 56. 54 is divisible by 9. The other one cannot. And 65 and 66. 66 and 67, not divisible by 9. And 76 and 77. 77 and 78, not divisible by 9. Next, 87 and 88. 88 and 89. These are not divisible by 9. If it's 98 and 99. This is divisible by 9. Now it cannot be 99 and 100 because x plus y. This cannot be more than 100. So we have found the values. Okay, let's just check for the corresponding numbers. First one, if x plus y is 45. Okay, x plus y is 45. Then look at this part. This 99 times x equals to 45 times 44. From there, we can find x. X is 20. So this is the number 2025. X is 20, y is 25. Second case, x plus y equal to 55. Actually, it will be easier if you just find the square number. So maybe let's just get a square number. The first one is 45 squared, 2025. Second one, the sum of the number is 55, so it's 55 squared, 3025. So it's 30 plus 25 squared. Third one is x plus y equals to 99. So 99 squared, 9801. There's 98 plus 1, then you square it equals to 99 squared. Asking for the other two numbers, which is 3025 and 9801. So we add them together. There's 12826.